Hello everyone, welcome you all in today's session. As we have discussed the algebraic structure of a set in the last video, where we have discussed the term group. So, what is a group? I said that if we have operation star that is defined on a set x cross x to x is well defined, we say this is a binary operation. Then we said that if under this binary operation this set is associative, means if we will take the elements a, b, c, any arbitrary elements of x, a star b star c is equal to a star b star c, then we say it is associative. Then again we see one property we have discussed, that is the identity. That means there exists this symbol, I use it for there exists an element e from the set x such that if you will operate it with any element of a set you will get the element itself. So that element is called the identity. So e is identity and it should be in the set x. We have seen another property that there exists one element from the set x which we denote in this way. We call it as an inverse. If a operate with that element will give you the identity e, that is a inverse star a. So this a is the, or this symbol a raised to the power -1 is called the inverse and it should be in the set itself. Okay, if any set will satisfy all these four properties, we say it is a group under that binary operation star. Along with this, if it is associative, means for arbitrary two elements and b, if a star b is b star a, so we say it is commutative. Then we say that this set x, which is a group, along with this commutative property, it is abelian group. And we have discussed some important examples in the previous video, which you can go through that one. Okay, so what is algebraic structure now? Algebraic structure, we say any set x with a binary operation, okay, with one or more than one binary operation, or we say that equipped with, okay, a set equipped with one or more than one binary operation is called the algebraic structure. For example, R along with plus and multiply is an algebraic structure. Addition, multiplication is an algebraic structure. Okay, so now as we have seen the definition of group algebraic structure, now what is necessary or important for our vector space जो हमें पढ़ना है, ओके, तो वो है फील्ड. ओके, फील्ड. सो यहाँ पे आप ऐसा भी ले सकते हो, रियल नंबर विद एडिशन ओनली, एक ही. ओके, इंटीजर्स विद एडिशन, जो आपने देखा एडिशन इज क्लोज्ड, तो एक से ज़्यादा जो ऑपरेशंस आप यहाँ पे लगा सकते हो, आप अलजेब्राइक स्ट्रक्चर कह सकते हो। और आपने देखा कि ग्रुप में जब हम कोई भी सेट लेते हैं तो हम विद रिस्पेक्ट टू एक ऑपरेशन ही लेते हैं। फॉर एग्जांपल वी हैव सीन आर with addition is a group, isn't? Complex with addition is a group, so we are taking only one binary operation. Now if we will discuss the field, तो field जो डिस्कस किया जाता है वो हम लेते हैं एक सेट, let's say x, equipped with the two operations *1 *2. Okay, these are two binary operations. और with respect to these two binary operations ये कुछ प्रॉपर्टीज होल्ड करनी चाहिए, ठीक है। दिस x शुड satisfy some properties. We will discuss those properties. So for example, if x is any set, x is any non-empty set equipped with two binary operations *1 and *2, okay, such that, or we will say a field x is any non-empty set equipped with two binary operations *1 *2 such that the following condition holds. The following condition holds. What are those conditions? First, so as we have seen, we have the set x with the two binary operations *1 *2. So first is that for any two elements a and b, if you will take from the set x, a *1 b should be again in x, and similarly, so it is with respect to the *1. Similarly, with respect to the *1, it should be associative as well, so it is closed. So if you have the three elements of the set, then it should be associative with respect to the first operation a *1 b *1 c. With respect to the first operation, there should be the identity, so there should be one element even from the x such that a *1 e1 should be a, that is e1 *1 a. Fourth property is that there exists the inverse, we will write it in this way, in the x, okay, or a prime, such that a *1 a prime, you will get e1, that is a prime *1 a. Okay, also it should be commutative, that means a *1 b should be equal to b *1 a. So these are with respect to the operation first one, and another 5 properties are with respect to the *2. So it should be closed with respect to the *2 if you have the two elements from the set x, then a *2 b should again be in your x. It should be closed with respect to this x. So seventh property is that associative. So a *2 b *2 c should be a *2 b *2 c. Means if you operate these a with the b, then with c under the operation *2, okay, it should be same if you operate b with the c then with a. Okay, then the eighth property is the identity. So there should be some element, let's say e2, in the set x such that a *2 e2 should be a, that is e2 *2 with a. And similarly, there should be the inverse, let's say a double prime with respect to each element of the x such that a *2 double prime will you get again here e2 it should be A double prime star to A, and the 10th property, it should be commutative. So we will say A star to B should be A or B star to A. You can check, it means that from these properties we can say that it should be abelian group, isn't abelian group with respect to star 1, and from these properties we can say that it should be abelian group, abelian group with respect to star 2. Also there is one another property that you call as a distributive property, that is A star 1 B star 2 C should be A star 2 C star 1 B star 2 C. So this is called the distributive property. Any set which satisfies all these 11 properties with respect to the two operation, then that set equipped with those two operations is called the field. For example, we will take Q under addition and multiplication. Okay, you know, as we have discussed it in the previous video as well, that Q with respect to the addition is an abelian group. That means if you will take any two rational numbers, then addition of the two rational number is again a rational number. Second, you know, the addition of the two rational numbers, or the addition is associative, okay, in the rational number. So we can say A plus B plus C. So rational numbers are associated under the addition. Third, you know that we have the E1 as 0, that is in Q, such that A plus 0 will give you A, that is 0 plus A. Okay, so this is the identity with respect to the first operation plus. Fourth, you know, we have the A inverse, that is minus A, okay, with respect to each element of the rational number A, so such that A plus minus A you will get 0. You know, fifth property, A plus B is equal to B plus A when where A and B are the rational numbers. Similarly, sixth property, you know, if you have the two rational number A and B, then multiplication of the two rational number is again a rational number. Okay, similarly, you have the multiplication, okay, of the rational number is associative. Okay, so that is A times B times C. Similarly, you know that we have 1 as a rational number, such that, so that is your E2, such that A times 1 should be A, that is 1 times A. You know, A double prime, which you get here as a 1 by A, is it, such that A times 1 by A will give you the 1 itself. And 10th property, you know, A times B is equal to B times A, and the 11th property is that A plus B times C will be A times C plus B times C. So Q plus and multiplication is a field. Okay, it is a field. Okay, so I think you will get confused here, that if A is 0, what will happen? It will be 1 by 0. But for a field, that is required that every non-zero element has a multiplicative inverse. So when we have a non-zero element, so then if we have P by Q as a non-zero, then its multiplicative inverse will be Q by P. So it is required for the non-zero element in a field. Okay, so similarly you can check that we have R plus with multiplication is a field, C plus multiplication is a field. So for your syllabus, we will take only these three fields in consideration of the vector spaces. Okay, so you can check all the 11 properties are hold here, all the 11 properties are hold here, all the 11 properties are hold here. Okay, let's go now to the concept of the vector space. Vector space. So here, before going to the vector space, don't just afraid of these terminologies, vector space, field. So these are just like the sets. Okay, ये सिर्फ सेट होते हैं, लेकिन इनका कुछ स्ट्रक्चर, एक पर्टिकुलर स्ट्रक्चर रहता है, कुछ कंडीशंस, एक्शंस रहते हैं जो इनको सेटिस्फाई करने होते हैं, तो अब हम इनको वेक्टर स्पेस कहते हैं. ठीक है ना. तो वेक्टर स्पेस में क्या होते हैं, यहाँ पे हमें दो सेट्स होते हैं. ठीक है, और हमें दो ऑपरेशंस होते हैं. इन दो सेट्स में एक को हमें प्रूव करना होता है कि वो वेक्टर स्पेस है, दूसरा जो सेट होता है वो हमें फील्ड होना चाहिए. दैट विल बी फॉर योर सिलेबस एदर दैट शुड बी सी, आर और क्यू, कॉम्प्लेक्स सेट और रियल नंबर्स और द रैशनल नंबर्स. और हमारे पास दो ऑपरेशंस होनी चाहिए. दैट विल बी गिवन star1 एंड star2. हमें कॉरस्पॉन्डिंग टू दिस हमें चेक करना होता है कि गिवन सेट इज ए वेक्टर स्पेस और नॉट. इसकी नोटेशन ऐसी होती है, एक्स जो हमें चेक करना है कि ये वेक्टर स्पेस है कि नहीं है, एफ ये गिवन फील्ड होगा और पहली ऑपरेशन होगी और दूसरी ऑपरेशन रहेगी. ठीक है, या एक्स के बजाय मोस्ट ऑफ द टाइम्स हम वी लेते हैं. वी इज़ एनी सेट, ये कोई गिवन सेट रहता है, एफ फील्ड होता है और यहाँ से star1 एक ऑपरेशन रहती है, star2 अनदर ऑपरेशन रहती है. ठीक है, तो हम वेक्टर स्पेस कैसे डिफाइन करते हैं, हम कहते हैं कि इफ वी इज एनी गिवन नॉन एम्प्टी सेट, ये आपको गिवन रहेगा. ठीक है, कोई आपको सेट देगा वी, आपको चेक करना है कि क्या ये वी वेक्टर स्पेस है कि नहीं, जो मैं अभी बताऊंगा कि इसके लिए कुछ ऐसे ही जैसे फील्ड में 11 कंडीशंस थे, इसी तरीके से वेक्टर स्पेस में भी हमें कंडीशंस चाहिए. ठीक है, तो हमारे पास सेट होगा वी और हमारे पास एफ. ओके, लेट एफ इज एनी गिवन फील्ड. ये भी फील्ड होगा, मतलब ये या तो क्यू रहेगा या तो आर रहेगा या तो हमारा क्यू रहेगा, आर रहेगा या तो हमारा सी रहेगा. ठीक है, तो हमें चेक करना है कि ये वेक्टर स्पेस है विद रिस्पेक्ट टू द टू ऑपरेशन. वो दो ऑपरेशंस भी ऑलरेडी दिए गए होंगे. ठीक है, तो हम क्या कहेंगे, तो ये जब ये एफ फील्ड है, ठीक है, तो इसकी ऑपरेशन भी क्या रहेगी. फॉर एग्जाम्पल एफ इज फील्ड, इट मीन्स इसकी दो ऑपरेशन रहेगी, star1 एंड star2, star1 and star2. So we say that let f be the given field in which elements are from either q, r or c in our syllabus. और v हमारे पास given any non-empty subset है. तब हम क्या कहेंगे, हम कहेंगे v is a vector space over f if it is closure, or we can say that if it is satisfies the vector addition and scalar multiplication. This V is any non-empty set with two operations, star1, star2. Okay, we say that it is a vector space over this field F if it is closure under the vector addition and scalar multiplication. Vector addition में इसकी कितनी प्रॉपर्टीज, 5 प्रॉपर्टीज है. स्केलर मल्टीप्लिकेशन में इसकी 5 प्रॉपर्टीज हैं. ठीक है, so we will say here V over F with star1 and star2 is a vector space if the following axioms following actions are satisfied. ओके, सो एफ विद रिस्पेक्ट स्टार वन स्टार टू क्या होगा, फेल। तो पहले 5 कंडीशंस को हम कहते हैं वेक्टर एडिशन, वेक्टर एडिशन, या कहते हैं हम इंटरनल कंपोजिशन, इंटरनल कंपोजिशन। इसमें 5 कंडीशंस आती हैं, ठीक है। दैट इज फर्स्ट कंडीशन, if you will take, so you have a set V here, understand this is your set V and this is your set F, and you know F has the 2 operations star 1 star 2 because it is a field, so it is abelian with respect to star 1, it is abelian with respect to the star 2. Now we will check V, okay, so here it has the elements V, U, X, Y, okay, so let U and V are the 2 elements of V, then we have the 2 operations star 1 star 2. So first we operate here with the star 1, okay, so in the internal composition we are taking which operation, the first operation star 1. So then U star 1 V should be again in V, means that with respect to the first operation it should be closed, okay, V should be closed. Second, with respect to the, because it is internal composition, to understand it, that here in this internal composition we will take the which operation, first operation, okay. So then with respect to this first operation it should be associative. If U, V, W are the elements of V, then U star 1 V star 2 W should be U star 1 V star 1 star 1 W, okay, with respect to the star 1 it should be associative. Third, with respect to this star 1 there should be the identity element which we call as a 0 of the vector. So that means there should be one element, we denote E or you can denote it with the 0 in V, such that A star 1 E should be A, that should be E star 1 A, okay, or you can write 0, ओके, ई के बजाय आप 0 भी लिख सकते हो क्योंकि हम इस वाले आइडेंटिटी को क्या कहते हैं, 0 ऑफ द वेक्टर स्पेस। फोर्थ प्रॉपर्टी इज दैट देयर एग्जिस्ट द इनवर्स, ओके, एडिटिव इनवर्स कहते हैं, तो हम इसको कहते हैं ए इनवर्स की नोटेशन में लिखते हैं इन वी सच दैट ए स्टार 1 ए इनवर्स शुड बी योर ई, दैट शुड बी ए इनवर्स स्टार 1 A. And the fifth property which it holds that A, okay, U, or I took A and B here, you can also use it U, okay, okay, don't get confused, आप ऐसा भी लिख सकते हो, ठीक है। अब U लिखा है तो हम वही फॉलो करेंगे, ठीक है। So now U star 1 V should be equal to V star 1 U, okay, so this is capital V, okay. So it means that if you will see, it is closure property, it is associative property with respect to star 1, it is identity with respect to star 1, it is inverse with respect to star 1, it is commutative property with respect to star 1. So we can say V should be abelian. So V is abelian group with respect to star 1. Okay, now more properties. Now more 5 properties we call as a scalar multiplication. Scalar multiplication property is that now here you took the elements within the V so that's why it is internal composition. Now we will take one element from F, another element from V, and we operate it with the another operation, that is our star 2. So the with respect to the star 1 it should be abelian group. Now with respect to the star 2 we will check the external composition. Okay, so that is, if we will take one element from the field F, one element from the vector, if you operate them, alpha is from F, U is from V, so we will use the second, because one is from F, one is from V, so they are from the two different sets. One is field and the another set V, so that will here we will apply the second operation, but the result should be again in your set V. Okay, that is the sixth condition. Now the second condition, seventh condition is that if you will take the two elements, since you know that this F is a field, so that means it is closed with respect to the star 2. So take the two elements, let's say alpha and beta are from the field F. Take the two elements and operate them with the star 2. So you know it's closed, so this element will be from the F, and U is from the V, so that is from V. So this is from F, that is from V, so these are from the two different sets. So we will operate the second operation, star 2. It should be alpha star 2 U okay, and star 2 beta star 2 U. Okay, clear? And even you can use the star 1 as well here. Okay, if you will use the star 1 here, the star 1 here, it will come the star 1. Okay, eighth property, if you will take now two elements from the V and one element from F, so take one element from F, two elements from the set V. You know U and V is closed under the first operation, so you will take U closed with respect to the V, it will be in V. And now alpha is external, so we will use the operation second. It should be alpha star 2 U star 1 alpha star 2 V. Okay, ninth property is that if you have alpha beta from F, U is the element of V, then alpha beta U should be alpha beta U should be beta alpha U, because you know beta and alpha are from F and they are commutative, so we can change it, and you can apply here star 1 star 2 as well. Okay, similarly the 10th property is that there should be one element, let's say you will call it as E prime, or you can denote it by the 1 in the field, such that E prime star 2 with any element of V should be U as only, that is EU star 2 with E prime. Okay, or you can write it as a 1, that is called a unit. If all these 10 properties were hold, then we say V over F with respect to the first operation and second two operations is a vector space. Okay, so thank you very much. In the next session we will discuss the different examples. Thank you.